Hi, everyone. While I get my screen share started here, I'll start with a little bit of background. So I am essentially picking up where Kafka leaves off. But one thing after another, shall we? Okay, I hope you can see my screen. Again, I'll be talking about user-facing analytics, and then specifically with Apache Pino. I already said, my name is Alexander Pucher. I'm actually, of course, a committer in the Apache Pino project. I'm also a founding engineer at Startree. I mean, I put my email there if you want to look it up, but I'm not going to waste too much time really, drilling in depth here. Maybe before I dive into the dog and maybe some technical details, I thought it might be a good idea to take a step back here and kind of give you an idea of where kind of Kafka and Apache Pino fit in, like maybe the whole analytics landscape, maybe a very simplified landscape. So if you look back in history a little bit, right, and you say you look at LinkedIn, and you look at LinkedIn's infrastructure, at least data infrastructure, then it is, in a very simplified way, two parts to this infrastructure. On the one hand, you have essentially stuff or events coming in, and you need to optimize for writing. And Kafka is really, really good for this, right? Essentially keeping track of events, making sure you don't lose anything, making sure stuff stays in order. And these individual events that come in, they're valuable and can drive an entire business. But at some point, this data becomes even more valuable when you starting to aggregate it, filter it, query it, really essentially generate insights from aggregates on this data. And this is more or less the read optimized part, so to say, of this data infrastructure. And this is really where Pino fits in. And of course, I mean, we've heard the awesome talk from Chris, right? Again, congrats to the IPO, of course. And the second thing is that Kafka is, of course, really good. KSQL DB has already many, many features that kind of help you with stream processing and dealing with some individual events and even doing some basic aggregation. But you also heard that Kafka is maybe not so great when you really want to do post-facto analysis, essentially ad hoc queries of the data. Meaning, for example, when you're doing, say, fraud detection, maybe an event like a payment request coming in, whether this is fraudulent or not only makes sense in the context of essentially all the historical information that you've collected up to this point. And this is really where Pino comes in, taking this real-time data and combining it with lots and lots of history, even ad hoc, even though you may not have been prepared for it in the first place. Okay, of course, also a little bit of business context, right? Of course, you've heard, right, there's Confluent, which got started from Kafka and got spun out of LinkedIn for a long time, and now they had their awesome IPO. And of course, Kafka is an open source project, but Confluent is, of course, one of the main drivers and had kind of like the founders and the creators of Kafka in there as well. And similar to this, you essentially have Apache Pino, right? It got started a little bit later because, of course, you first need to collect data before you can really analyze it. And now out of this came Startree about 2 years ago, which also has pretty much the creators of Pino and also came out of LinkedIn original and is now kind of running on its own. I myself, I've been kind of involved in Pino and like with the people behind this platform since about 2017, so good 4 years now. And it's been an awesome journey. Okay, of course, I have to give you the obligatory pitch. What does Startree do? I'm not going to bore you too much with the details, but of course, the open source project of Apache Pino is awesome. It integrates with everything. Everything you'll see in this talk works with the open source Apache Pino. And then if you want managed deployments or you want some enterprise integration or maybe you have some compliance needs, then you can come to us. But again, this talk is mainly about Apache Pino and how it powers user-facing analytics. Okay, so of course, what better way there is to start a talk about user-facing analytics than trying to define what that even means? And I came up with a 2-line blurb, essentially saying that user-facing analytics, in the widest sense, is operationalized data that everybody relies on. Essentially data that your users rely on, data that their users rely on, and then even data that maybe the end user or a consumer relies on in the end. Essentially, transitive processing of data that all ultimately depends on one source of truth of data. And when you hear about analytics, of course, then, well, you have an analytics pipeline in mind, right? How does this look like? I mean, we saw some examples of what an analytics or a batch processing pipeline can look like, right? In the simplest case, might be something like this. I mean, again, you can swap out the technologies, right? But essentially, you have some kind of source of events, like maybe it comes from, a SQL data store and you use Debezium for change capture, or it comes directly from a web app or maybe a mobile app, and it goes into some kind of streaming platform. For example, Kafka. I mean, Kafka is really good at this, right? And then eventually you take those events, you put them in store, maybe in a data warehouse, and then this warehouse powers, in the simplest case, some form of dashboarding or maybe reports that are being sent out. Now, of course, this architecture already looks like it has some history. And if I take a step back here, really, and I don't just look at the technology, right? I really think about, well, what are we trying to achieve, right? When we build these things, ultimately, it comes down to solving a problem in an organization, right? We have a business problem. We want to make decisions. Usually, we want to run a business, and we need to make decisions in an effective way and in a data-driven way. And so getting to this point of even making data-driven decisions and essentially leveraging user-facing analytics to get there is also a process that is kind of ongoing. It is more a very organic process. And of course, depending on kind of what organization you're in, this process might be very familiar to you, or it might be like a solved problem. If this is a process and you're just getting to the point where you're making data-driven decisions, then this development there is what I like to refer to as the 5 stages of user-facing analytics, if you want, in an organization. I like to break it down into pretty much 5 stages: the denial phase, the anger phase, the bargaining phase, the depression phase, and ultimately acceptance that indeed data is required to make effective decisions. And of course, everybody who has seen this knows that not every stakeholder goes through these phases in the same order and at the same time. And it's, it takes some time, but eventually, I mean, if it brings value, it ends up happening. And even though this is not frictionless and stuff happens, there's also another thing that happens, and that's data products. And these data products is then really what Pino also tends to power, but one thing after another, right? So I said data products grow organically, right? You already thought like, oh, here's a dashboard. Well, here's a report that comes out. Maybe here's a view, maybe even a self-serve platform. The funny thing is that every area of business, every use case is kind of different and unique. But even though this grows organically and it is unique in its space, kind of the process of creation in a data product pretty much always follows a predictable pattern. And this predictable pattern for the product is kind of just a different way of looking at it from the process of the organization. Right? Of course, when I look at the stages of product development for a data product, I only have 4 stages, because when my organization is in denial, well, I don't have a product yet, but I'll get there eventually. Right? And it usually starts with pretty much a simple dashboard or report that goes out, right? The dashboard phase that I like to call it. It's just operationalization of data just for basic monitoring and planning. And as soon as you start picking off like essentially the low-hanging fruits, right? People notice, oh, this is actually really helpful. Oh, we actually caught something that nobody would have noticed. Then people start coming to you with more and more requests, right? And it's like, oh, we need more customization, more metrics, more dashboards. And at some point, no matter how many analysts and like data engineers you hire, you just don't scale manually. And you kind of enter the second phase, pretty much this tool phase of this product or data product development cycle, where you add self-serve capabilities, right? And so now your customers don't have to talk to you directly, but they can just grab the data and do their analysis. And this kind of fluidly transitions over into this platform phase, where suddenly you start having APIs, and then your users suddenly start building, say, front ends that then suddenly serve their users, or self-serve capabilities for their users. And you start having these first transitive dependencies, right? Where there's somebody that you've never talked to, somebody that you may not even know exists, that suddenly consumes your data and also ultimately depends on you, right? So if suddenly the source of data is gone, suddenly this whole chain here starts complaining all the way back. And eventually, of course, this data also finds its way to an end consumer or to a vendor, for example, at which time it really becomes a data product, right? Something that maybe even drives bottom line growth for the company, right? Whether it's actual dollar revenue, or it's just based on driving growth or maintaining retention of customers. And it's, of course, it's always nice to talk about this in a high level. So I figured instead of just boring you more with these concepts, I'll give you an actual data product in action. And I just grabbed this from UWIS, actually. So I mean, this is it's just pretty much a simple dashboard, but still a data product. That's the so-called restaurant manager to Waits. So when you order food, right? I mean, you scroll through the menu, you pick something. Eventually, this order gets sent to the restaurant. They prepare the order. Then eventually, somebody picks up the order and ships it to you. And there's actually many, many different things that are involved here, right? From processing payments to actually preparing the order, from the logistics to getting it to you, and everything in between, including customer support. Now, even though this is just a simple dashboard, you already see there's quite a bit of complexity, right? That you may have some customization, like certain date ranges that can be selected by the restaurant owner, maybe time series that shows them how the business is going, some slicing and dicing. Like maybe I should have called it maybe aggregation or filtering, right? Where I said, hey, these are the orders that are missed. I thought these are the orders that are late. Maybe some ranking, right? Telling me, hey, what are the top selling items and what should I make more of? And maybe even some customized, like fine-grained statistics or even outlier detection, right? That says, hey, for your restaurant, well, essentially, what is your SLAs, right? What is your downtime of your business? And having a data product like this, I mean, it's obvious that it's valuable because you need it in order to really make these logistics happen. But it's actually, with some effort, you can build an application like this and make it happen as a prototype, pretty much regardless of which technology you use. And that is fine until you get to a point where this product gets adopted, right? If you have a data product that really starts seeing uptake, right, and people use it and interact with it, then you suddenly have a scalability issue. And the restaurant manager is actually a really good example of this, right? Because this application here is literally used by over 500,000 different restaurants. Right? The application itself runs at around 1,000 QPS, right, during peak times. You expect latencies of essentially under 100 milliseconds, right? So it should be real-time and responsive. And most importantly, the data should be fresh, right? I mean, you cannot ship orders in batch like every 1 or 2 hours, because at the point where you start cooking, well, the customer just wants the money back, right? So suddenly you're in the situation where, well, yes, you're showing and you're shipping analytics, but you have all of these production SLA requirements, right? It has to be fast, it has to be dealing with the throughput, and it has to be fresh as well. And it has to be available all the time. And of course, if you want to achieve this, then the classic like batch analytics infrastructure that I showed you doesn't really cut it. And you have to augment it, right, to deal with real-time requirements and other things. And so usually, at least in theory, you end up with something like this, right? You still have your analytics pipeline, right? Something goes into Stream, something goes into your warehouse, and then you use your applications. But you also suddenly have this real-time track on there, where you say, oh, well, maybe now we need a second track that takes care of real-time events, right? So they don't have an hour or two delay, but everything happens within a minute. And I have essentially two types of data stores, like real-time at warehouse and multiple applications interacting with it. And I can I can actually already see people laughing, because if you've ever built like a Lambda architecture like this, like so real-time and batch analytics, you of course know that this architecture here, as a Druid, is purely hypothetical. And in reality, it looks more like this. And when you end up with something like this, then complexity becomes the enemy. And you're spending most of your time just keeping it running and making sure everything holds together, rather than really maybe expanding your product and essentially getting to the next stage of value creation. And because you have complexity, of course, you also end up hearing from users and from their users and sometimes from end users. And then the questions may look like these. Yeah. So some of you are probably still laughing. Maybe someone's, I'm sure someone's crying by now, but that's okay. It's okay. What I want to tell you is that it's okay, and actually you're not alone. In fact, I think every single data product that I've seen that has become successful at some point went through this pain phase, right? And even though every pretty much use case is unique in the challenges that you come up with, the building blocks that they usually use to address these questions, right? To deal with all of this complexity to essentially just get the product to the next level are the same across many different domains, whether it's, food delivery or financial transaction processing or anomaly detection or building a data lake for an entire company or maybe machine learning features. There's a couple of fundamental analytics building blocks that just come up over and over. And the funny thing is the following. Do you remember the slide from before? Usually, if you just go long enough, an analytics data infrastructure ends up converging towards something like this. And I don't mind, I don't want to say that it has to be Kafka and it has to be Pino, but essentially you end up with a right optimized layer on one hand that makes sure that all the stuff is being kept track of and everything comes in order. And then on the other side, a read optimized side that helps you with ad hoc requests, adapting to changes, scaling with requests, like taking care of all of these issues. And of course, Pino historically comes out of a setting, right, where there was lots and lots and lots of complexity, and people tried to just reduce it, right? Reduce the amount of stuff that you need, right? There's some things that always show up next to each other. Can you just take all of this complexity and kind of slowly pack it into one box so that you don't build a huge Lambda architecture, but you just have this Lambda architecture in a box? And this is really what Pino tries to achieve, where you say, hey, well, if I use Pino, Pino takes care of data freshness and consistency, right? You have a batch data source, you hook up your Kafka topic, and it takes care of deduplication and just gives you your results on the fly with accuracy. And you want to serve with production SLAs, right? You want the system to be available, you want it to scale, you want it to be elastic, you want it to be fast. And you also want it to adapt to new ad hoc queries that come in, right? Essentially, I don't want to have to change 4 pieces in my infrastructure just because I want a new metric or I want a new filter. Instead, I just want to fire off a new request and I want to give it an answer. And that, of course, feeds into the third point, which is it makes me way more productive, right? And it simplifies operations if there's 1 or 2 log files that I look at, or I just send a new request because I want a new filter and I don't need to go back and tweak some pre-materialization view somewhere down the line that just feeds into my key value store. And I don't want to tell you, oh, throw away your data analytics infrastructure and replace it with Kafka and Pino. You probably could, but you don't have to, right? Because Pino comes out of this historic context, right? Where it says, hey, well, I have all of this complexity and I kind of need to deal with it and like iteratively onboard things and like essentially slowly absorb more and more use cases and reduce the capacity. It still integrates with lots of different systems, right? It integrates with different storage backends, right? All the cloud backends. It integrates with different file systems. It integrates with different streaming connectors, right? You don't have Kafka, sure, use Kinesis, this is fine, right? There's like many, many ways how you can get data into Pino, even out of your existing warehouse, right? Like you want to take your data out of Hive, sure. You want it out of Snowflake, okay. There's a connector for this, right? This, of course, rings very similar to what Kafka Connect does as well, right? Where you say, hey, this should be a platform that solves a problem and then just connect to all the technologies that you may have around it so that you can easily just try it out, deploy it, see if it works for you. And if it does, you can pretty much consolidate more and more functionality into this so that instead of having 20 things running, you have 2 or 3. And so, in other words, Pino's built from this experience, right? I mean, Pino has been deployed, of course, it comes from LinkedIn originally, and then also Uber adopted it very, very early. But there's literally hundreds of use cases across different companies that run Pino at scale, right? I mean, you can go to Microsoft, you can go to Slack, DoorDash uses it. There's plenty other major fintechs that now rely on Pino. And it's really gotten to the point, right, where this experience is built into the system, and many problems that just come up repeatedly essentially add to the toolbox of Pino, right? So Pino is not just like a silo and saying like, oh, this is a solution. It either works for a use case or it doesn't. It's more multiple building blocks that can be combined to make the right situational trade-offs for a specific use case. Saying, do I need high availability? Do I need scalability? Do I need all of these things? Yes, maybe partially, no. I just want to be able to take these things, essentially configure them together instead of hardwired in an architecture. And if it turns out that I need to change the trade-offs that I made before, I can do so on the fly. So in other words, I want to bring together all the building blocks into one place. And I mean, I put this long list there on the side where we said, oh, here's different indexing techniques and encoding techniques, and this is how we deal with high availability. And SLAs. The bottom line is, Pino has quite a bit of mileage on it. And so therefore, it is not just one monolith that just either works or doesn't. It is really a toolbox, and you don't have to use all of Pino. There are just some parts that might be very helpful to find a solution for your specific use case. Okay, I already mentioned this. I mean, obviously, like one of the main ideas behind Pino is that ultimately, whatever I do, I want to be able to, in the end, serve production-grade traffic, right? So of course, when I start with a data product, right, I'm like, it usually starts as a prototype. Actually, many awesome data products that I've seen start as just something that is thrown together as a quick hack, right? And then it sees adoption because, well, it solves a really important problem. But the other side of this is often that, well, yeah, when you throw together a data product just as a prototype, well, it doesn't really matter to you whether it scales or not, right? If nobody uses it, then why would it care if you scale? So scalability becomes kind of this afterthought, but there's a tricky thing here, especially when it comes to dealing with this from a product perspective again. Namely, that scalability doesn't really matter during this development process of a data product until the moment where your product suddenly sees uptake. Pretty much at the most important moment when suddenly there's more and more traffic than you ever expected hitting this product and seeing use, suddenly at that point, scalability becomes a problem. And you don't want to be in a situation where at that point, you have to rebuild everything. And this is really where Pino comes in. And you've seen this like crossing the chasm chart, right? One of the key concepts behind Pino is you want to scale from 0 to production traffic smoothly without having to re-architect in the middle, right? This was probably one of the key drivers behind building a system, right, that brings together all of these components of the Lambda architecture into one system. Because the moment where you see uptake in a data product, you want to be able to just tune up the volume, so to say, and get a larger cluster and be able to deal with the traffic, rather than having to replace infrastructure components and essentially start from scratch with a V2. So, you want a large deployment? Sure. I mean, there's enough deployments that look like this, right? You have Kafka on one side, HDFS on the other side, and then Pino in the middle getting hit with 10,000s of QPS that have some very, very sharp SLA on maybe their latencies and their availability. Essentially, if you go, I don't know, if you visit LinkedIn, for example, pretty much any number that you see on LinkedIn is served by Pino. And usually the Pino cluster behind it looks something like this. On the other hand, right, I said, right, it's better as it's not just Pino. Because it's used in production, right? You know that the system has a high availability. It has been built to the point where, yeah, there is no single point of failure. There's, you want to be able to upgrade your cluster, or modify your cluster, scale your cluster, reconfigure your cluster without downtime, right? These are all essentially traits of a real production system. And on the other hand, well, this sounds like it adds quite a bit of complexity. So I want to make sure that I make this point here that these things are great to have and they are available, but they're just another tool in your toolbox. Essentially, it's not forcing you. Meaning that if you want to have high availability, yes, you can replicate everything, but maybe you don't need to for your specific use case. Maybe there's only some fine-grained things that you want to replicate. Or maybe you're just doing some dabbling around and actually building that small prototype to find out if it works. Maybe you don't want replication at all, right? Essentially, you want to be efficient and cognizant of the resources that you use, right? This is another key point in the design of Pino. Not just, okay, production level SLAs, but also efficiency in resources. And with this, I mean efficiency in the widest sense, not just compute and storage so that you hit your SLAs and your scale, but also your development time and the time of your teams and engineers. So already suggested, right? You want to start with Pino in a box, you can. I mean, you can literally download a Docker image, push a button, and you're up and running, and you can just try it out. I mean, it really works this way. And then as you play around with it, you can dynamically reconfigure it and scale it. In fact, you can scale very far. I mean, you can get to large deployments with high availability, right? Where you have multiple groups of real-time consumers that are fault tolerant. You can have like an offline group of servers that scales, shipping data between those two, so that real-time group is just the size that it needs to be, and the offline group just holds the data. And of course, you have fault tolerance. That's, all of this is good. The message is you can get there. You can have scale, you can rebalance, and you can reconfigure dynamically. And you can actually do it at runtime, even when you have a system run. So essentially, just back to the point, hey, you can go from 0 to very large smoothly without re-architecting in the middle, and also by taking advantage of these tools like high availability when you need them, but not waste resources on them if you don't need them. Oh, and of course, right now, people usually don't run deployments on bare metal anymore. Some people still do. But unless you have a very large deployment, right, you often see deployments of Pino in the cloud now. Right? So Pino has quite a bit of adoption in pretty much cloud-native environments, usually running on Kubernetes, sometimes on custom container frameworks as well. And you go ahead and say, well, I actually, scalability and all of this is nice, but, essentially don't bother me, like tell me essentially when you need more resources and get them yourself. And so then, of course, you now see Pino and it integrates with, some of the cloud stores, of course, Kubernetes as managed service on many cloud platforms and so on. Anyways, I mean, there's lots of background about this. There's lots of talk. It's very easy to just type into Google, say like, hey, Apache, Pino, Kubernetes, and then you'll see lots of things popping up, including some talks about the details here. Okay, now all of this is, of course, kind of like a pitch of Apache Pino, and maybe not too much in depth. So I figured as a last thing or a last key concept that I can bring up, I'll be a little bit more technical because I mean we've seen lots of technical depth also in the previous talks. So I also want to make sure that I kind of keep up with that. And probably one of the most interesting things here is domain-specific indexing in Pino. I mean, if you have a database or analytics background, you know that oftentimes when it comes to solving pretty much SLA issues or just accessing data efficiently, indexing is the approach that you use to just deal with many challenges and perform some optimizations. But of course, it turns out that every different domain has its own challenges, right? I mean, sometimes your basic sorted or inverted index does the job. Sometimes when you deal with, I don't know, geolocation, suddenly you want completely different indices. You have time series, you can compress it in different ways. Maybe you have some super high dimensional, like wide machine learning feature tables, right? All of these different things and data structures have its own different challenges. And so Pino ended up implementing lots of different indexing techniques that you can essentially choose on the fly, right? So as you ingest data, you use Pino, you see, okay, well, maybe I'm starting to see some performance issues. You essentially just flip the switch on one of these indexes if you're especially in one specific area, and then you create this index on the fly. You just start leveraging and benefiting from it. And of course, one of the, I guess, the signature indexes in Pino is, of course, the star tree index, which also gives the name to our company. But first things first. Right? So let's just start with a simple example here. Right? So let's say I am in a forest and I want to count the number of leaves. And we'll just say that we only want to count leaves that happen to be still on trees and they happen to be green. Now, if I look at my standard solutions in analytic systems, I'll usually see three different approaches, right? I can do a raw scan of the data, which is fine, maybe if the data is small. I can go a step up and maybe, I use my inverted or sorted indices, and the performance might be okay depending on essentially how the distribution of the data looks like. Or I can say, oh, I need to hit really, really, really severe and critical latency SLAs. I want to pre-materialize all the results here. Right? These are, like, say, three typical approaches that I see. And of course, well, if you pre-materialize, okay, you can be really fast, but you kind of have a storage overhead. Yeah. Of course, I'm kind of laying out the path already to come in and explain a little bit about what the start tree index is all about. Because again, here you see that it seems like that every approach that you take is kind of like fixed somewhere in your decision space, right? If you say, okay, I only have small data, I'll just scan the raw data, I'm kind of on this extreme. Whereas when I say, oh yeah, I'll just pre-compute everything, I'm on the other extreme. Maybe where I want to be on this scale, essentially how much resources I want to use or how sharp my SLAs are, should change dynamically depending on my use case, depending on how it gets adopted, right? Essentially, as a scale and as a C user in my product, I want to change dynamically where I am on the sliding scale. And this is really what the start tree allows you to do as an index. So, I mean, this is just going to be a very basic example, but if you look at aggregation, right? So, for example, the summing leaves here. The start tree index is essentially a tree-like structure where I say, okay, I have essentially these pre-aggregated nodes, and they only sit around if there's lots and lots of rows to scan. So essentially, I can tweak more or less dynamically what the depth of this tree is and essentially what the fan out of the trees. All of this happens more or less dynamically based on some SLA data set. And intuitively, you could say, you could set an SLA based on latency, for example, and saying, well, in order to hit my latency SLA, I can never scan more than 50,000 rows of data. And I can take this information and essentially from there compute, well, what does the structure of my start tree have to look like in order to get there? And then if a query comes up, I can simply leverage this index item and say like, okay, well, clearly I'm aggregating more. I want to filter down by location, right? So I just go down this path, or I want to filter down this color. And then every node just either has the references to the data or it has some pre-aggregation results. And the interesting thing with this is that I can on the fly just adapt how deep or how wide my tree is. And at the same time, if I want to add additional features, for example, now I want to group by a new dimension, like a shape dimension, more or less ad hoc, I can simply add this and reconstruct and update my index. And so I can still serve this new pretty much ad hoc query that showed up post facto and still cater to an application in real time on the fly without re-architecting a data infrastructure in the first place. And so then, of course, you look back and you say like, oh, well, of course, in a perfect world, you then end up with a start tree index that gives you both good performance and good storage. Of course, with good being whatever is just right for the use case that you're working on. And so essentially, this comes down to the last important point, right? I said domain-specific indexing is a tool, but what it really enables and what production SLAs, as well as also the efficiency of resource usage enables, is to be able to serve ad hoc post-facto queries at production SLAs for next-generation data products. Because if you can just rely on a platform that you know will ingest your data and will serve your needs and will scale with your needs over time, you can focus on actually driving the value and building the products, really coming up with the next thing, right, that makes the product the next driver of growth or revenue, rather than dealing with handling architecture and so on. And there have, of course, been many, many different use cases implemented. I mean, of course, LinkedIn's data lake is on there. There's various visualizations. There's A/B testing platforms that were built on that. Of course, machine learning model, like feature repositories. Anyways, again, just Google, Apache Pino use cases. There are many, many blog posts and talks about it in the meantime. And it's generally awesome to see. And similar to, of course, how I kind of I pitch Pino in this way. I'm also glad to see that we actually have quite a bit of community adoption in the meantime. And we know, so we did a community survey some time ago, right? And they said like, well, we know of at least 50 different companies that deploy Pino in production. We have a very active Slack community. Actually, this is pretty awesome. It's 1,400 people. There's, of course, it's open source, right? So there's a GitHub repository for it, plenty of community contributions there. And we also try to kind of summarize some of the larger deployments that there are. And I mean, we've seen essentially ingestions of over 1 million events per second, cases where hundreds of thousands of queries per second are answered, even with millisecond latencies. And I have to say, this is actually, it makes me really happy to see this adoption, because there was a lot of hard work going on behind the scenes, right? From different engineers, from different contributors. It has been quite a big effort, and it's very, very awesome to see that now this is also being rewarded with adoption. And this is really where I also kind of want to close the loop and pretty much wrap up my talk and just say that Apache Pino powers user-facing analytics. Apache Pino is open source, right? It comes batteries included, and whether you want to go the enterprise route and you want to talk to Startree, or you just want to tip in your toes and you want to look at open source, both of them are really awesome. And of course, I'll be here to answer questions. You have my email at the beginning of the talk as well. And but probably the most, like the easiest way to essentially just dive in and look at what Pino has to offer and the community has to offer is to just join the Apache Pino Slack channel. I mean, again, with over 1,000 people there, they have lots and lots of experience building on top of Pino. And that's usually the best way to just find people who help you out and point you to the right place. OK, and with that, I'm done. Thanks very much.